When we want to convert a recurring decimal to a common fraction, let's just make that pen a bit smaller, a recurring decimal to a common fraction, we want to look out for a few things. Number one, recurring decimal can be written like that, or it can even be written like that, where the 6 now is the only recurring decimal. 2 and 3 are not recurring, only 6 is recurring. Or we can write it like that, with a line over it, and 2, 3 is then recurring. So that would be the same as 0, 2, 3, 2, 3, on and on and on. Now here's the point, you need to be very careful here. We have a normal fraction, and when we're converting a normal decimal, 0, 5, and we look here and we say there's no dot on top of it, no line on it, that's in the 10th position, that would be 5 over 10, 1 over 2, if we simplify it. But when we have recurring decimals, they look like this. We've got a certain structure. So let's do two examples. First example, convert 0, 1, and there's my dot that I was looking out for. 0, 1, that's a recurring decimal. Convert 0, 1 to a common fraction in its simplest form. So the first step is now to let this 0, 1 be equal to x. So we write it, let 0, 1 recurring be x. And we'll let x be equal to 0, 1 recurring. So I start that, because what that 0, 1 means, 0, 1, 1, 1, 1, 1, 1. Looking at this that I've just written, this 0, 1, 1, 1, 1, 1, on and on and on, what I want to do is get my first recurring digit, this 1 here, first recurring decimal, I want it on this side of my comma. And we know to do that, to move the comma one place to the right, we simply multiply by 10. So that means if I multiply this by 10, I'm going to get 1, 1, 1, 1, 1, on and on and on. But what I do to the one side, I must do to the other. So if 0, 1 is equal to x, and I multiply that 0, 1 by 10, then I must also do it to x. So therefore, 10x, oh that's bad writing, we can use that sign for therefore, 10x is equal to 1, 1, 1, 1, 1, on and on and on. Subtract what we started with, we subtract x. We subtract x on the left hand side, we subtract x on the right hand side. Draw our subtraction line. And now we start subtracting. So that 1 is going to cancel out with that, and that's going to cancel. And all these decimals are cancelling out. And what I'm left with is 1 minus 0, which is 1. And 10 minus 10x minus 1x, 10 of something minus 1 of something, is 9 of something, 9x. When we get to this stage, we want to get x by itself. And that means 9 times x, and the opposite of multiplying by 9 is to divide by 9. If I divide that by 9, I get x by itself. But what you do to one side, you do to the other side. And that, if you go and put in your calculator, will give you 0, 1 recurring. So I've taken this recurring decimal and written it down here as a common fraction. So always remember, start with let your recurring decimal be equal to x. And remember to move your decimal. We want to move it one place to get this 1 back over here on that side of the decimal. So if we do it here, multiply by 10 to move it one place, then we must do it here to get x, 10x. You see it more clearly in the next example. We've got 0, 24 recurring. So that is, sorry, not 0, 3, 24, 24, 24. So it's going to go on and on and on. We start with let 3, 24 recurring be equal to x. Notice the 2 and the 4 are all recurring. That's recurring, that goes on and on and on. So now what do we multiply this by to move the recurring part to the left of the decimal? Well, if I multiply by 10, I'm only going to land up there. So that's not far enough. I need to multiply by 100. If I multiply this by 100, I will have 3, 2, 4, it's 324, comma, and the recurring carries on 2424, on and on and on. So we multiply our decimal here by 100, we must multiply x by 100. So we have 100x. can say, therefore, 100x is equal to 3,24. 324. Sorry, I keep saying 3,24. 324,2424. Next step is to subtract x on both sides. So there's my subtracting x. And on this side, x was 3,2424. See, by moving my decimal 2 places, I've lined up, when I'm subtracting x in this line, I've lined up all my decimals. The 2's underneath, the 4's underneath, the 2's, the 4's. So when I come to subtracting, let's do the left-hand side. 100 of something minus 1 of something is 99 of that something of x. When I subtract here, notice my 4's are cancelling, my 2's are cancelling. All the way I've got no more decimals remaining, and 324 minus 3 is 321. Good. Now when we're here, we said in the last slide we wanted to divide by what's next to x, because this means 99 times x. If I divide by 99, they're going to cancel each other out, and all I'm left with is x on that side. Perfect. What you do to one side, you do to the other. So that's 321 on that side. Now, 301 divided by 99. Divide both sides by 99. When I get here, this word, simplest form, means I must see if I can simplify this fraction anymore. And I can. I can divide both the top and the bottom by 3. If I do that, 321 divided by 3 is going to give me 107. 99 divided by 3 is going to give me 33. I can look at that and say 33 goes into 99 3 times, and it's going to leave me 8 over 33. Right? And underline my answer. And so if you put that into your calculator, again you'll get this recurring decimal written here as a common fraction. Watch this a few times, do a couple of examples, make sure you understand the difference between converting a normal fraction, a decimal fraction, and a recurring decimal. Hope that helps.